How's it going, everybody? It is Ethan Koder, and welcome back to Devlog index number 1. Unfortunately, the office/studio is not quite ready yet, so it's going to be virtual background for now. Hopefully by next episode we can get the recording set up all good. Have you ever wondered how your browser is capable of actually taking a file that's just some words and text and displaying things like this YouTube video as you're watching right now? So if you've ever wondered this, that's great, because today we're going to be exploring how we can take that HTML file and produce some working DOM object. In our case, we want to create this DOM virtually. That way we can easily and quickly access different elements from the HTML file that we got from the internet rather than actually trying to display the page. Since our use case is slightly different than a normal internet browser, we'll still be following some of the directions of the HTML specification for an HTML parser. However, some smaller things like taking the file in as a byte stream will be ignored since we are not accessing it at a network level. Rather, we already have access to the entire text file whenever it reaches the parser, so we can just kind of treat it like a string or a character sequence. By the end of the video, both you and I will have a better understanding of how to take a file with just text and turn it into a web page. As always, I'm Ethan, otherwise known as Koder, and I enjoy developing this project and playing games while I'm not training others to be software developers. So let's go ahead and hop straight into the development. Originally, I was going to use a library called Selenium to actually parse in the HTML on the websites for me. The only problem with Selenium and other Selenium-like tools is that they're rather heavy to run because they literally open an instance of Chromium in the background and navigate to the site this way. Now imagine having hundreds or possibly even thousands of threads opening headless browsers like this. We could quickly run out of system memory or run up a large AWS bill if we were to continue this way. But instead of using a library like Chromium, I realized that every time you type in an address in the top of the browser, you're essentially just doing a GET request, and that gets the returned HTML document that you want from that server. So making these requests and getting the physical HTML file from the server is much less intensive than having tons of web browsers open to parse for elements in a simple file. With this thinking, we are going to switch our focus from writing the proxy server first to writing a service that can make a request to any website that we want, get the HTML file from their server, and then turn the HTML file into a Java object that we can easily parse programmatically without the overhead of running Selenium. So the next question is, how are we actually going to do this? We actually have to take a step back even further and take a look at the very basics of HTML. As a programmer, we can think of HTML as a tree-like structure where the root of the tree is a single element called HTML, and then from there it branches off with elements having children and so on and so forth. The main two elements inside there would be the head and then the body, and then inside the body we'll have other elements such as divs, paragraphs, H1s, H2s, things of that sort. So this means that we can create a tree-like object as we parse the HTML page with our Java program. So how do we actually parse this file? Luckily, the fine people who manage the HTML technology have laid out exactly how to parse an HTML page, and we'll be following that algorithm. The basic rundown is this. So first we make the request to the HTML page, which will end up being a string for us. Realistically, this is supposed to be a string of bytes or a buffer of bytes that is coming through a network. But again, since we're not actually displaying this as a web page, we can just get the entire HTML page as a string. We're going to feed that text into what we call a tokenizer, which is going to read those files or read that string in character by character. This is what we will be focused on during this episode of the devlog. Next, we tokenize the page according to the rules set out in the HTML specification. Step 4, we'll take those tokenized and create the DOM tree according to the HTML specification, and then finally we will return that DOM tree. So with this being laid out in our plan, we can go ahead and hop onto a computer and do some planning and write some of our code. Are you enjoying the content? Maybe learned something new? Please make sure to hit that like button below if you are in fact joined, or if you're not, go ahead and leave a dislike. Also, if you have some feedback, good or bad, I would love to hear it in the comment section below. All user interaction helps me out a ton with this YouTube algorithm. So while you're at it, also make sure you hit the subscribe button below. It's free. And if you hit the bell icon, you can also give you alerts when I post new content like this. So let's get back into the video. Before we even started writing any of our Java code, we needed some way to actually get an HTML file from a server, and I didn't really want to grab some crazy HTML file from someone's website, so I just wanted to have some sort of default or very simple HTML page. So that's why the first thing we did was create a Node and Express server that simply serves a simple HTML file. This is what we're going to practice parsing before stepping up to the big leagues, like I was saying before. Then in our parsing service, we need some way to actually get the HTML page. I'm not 100% completely following the spec like I said before, because I'm not actually looking at the page as it comes in byte by byte. Instead, we're making a simple GET request with the Spring REST controller and the use of a REST template. This returns the HTML as a HTML/text response, and then we can convert that to a string with our REST controller. Once we have the HTML string, according to the specification, we must only have a certain type of new line characters in our string, so we must pre-process this. Here's where I create the byte array that then gets converted into a byte list to simulate an unlimited size byte stream. While creating this list, we also get rid of the incorrect new line characters as well. Next, according to the HTML spec, we need needed several types of tokens to be emitted during the tokenization process. I created 5 different classes to model these 6 tokens. 2 of the 6 tokens were starting tags and end tags that had the same attributes, so I just shared the same class. I also created a marker interface to mark all of these as a token. So the reason why I did a marker interface instead of just a token class is because all of the different tokens had completely different attributes, but I still wanted to define methods later on in the feature as returning a token and had the freedom to return any of those 5 classes. So realistically, I didn't have enough attributes that were actually shared between all of the tokens to make a parent class. So with our tokens out of the way, we could actually start the logic for our tokenization algorithm. I went ahead and went through the HTML spec and created every possible state as an enum, and this literally took almost an hour. There's so many states. And I also created a switch state method, which will take in our input character or our next input character and decide which the state was and any tokens that we need to emit at the time. However, this is where some trouble began, and I started realizing that I made some mistakes and some other things along the way. So I started with going from the top state and going down. Then I realized that this was going to take way too long because realistically, you're only going to go through so many of the doc type states and things like that. We didn't need to do all the extra stuff. So I really wasted a bunch of time, and I realized halfway through that I was not going to nearly have enough time to make any real progress. So that's when I switched on focusing on just getting the first line of the HTML parse or the doc type declaration. The first line, like I said, is a doc type declaration, and just to get it parsed, you're probably going to pass through at least 10 states. It was attempting to parse in this first line when I started to realize I had so many design flaws and so many mistakes whenever I just started writing this because I didn't really have a plan that I needed to make some decisions and make some changes before too long. Before moving on, I just want to let everyone know that as soon as I get moved and situated, I will be actually live streaming on Twitch at least every single Saturday morning on this project, and possibly even playing games during the week. So be sure to head over to my Twitch and follow me at twitch.tv/unknowncoderyt. Also, to keep updated with where my videos are and streams are, follow me on Twitter at twitter.com/unknowncoder. After a good long coding session on livestream Sunday, I started up again on Monday night, determined to finish parsing this very first line of HTML, and everything was going fine until the design decisions and overall logic errors really started to pile up for me. So it was around this time I was attempting to parse in the type of the document being declared in the declaration that I decided it was time for a complete refactor of the switch state method. The first major issue that I encountered was that my use of next input character and current input character were just straight up incorrect. I need to go ahead and correct this logic for any of my parsing to actually work the way it's supposed to. Currently what I'm doing is I'm setting next as the current character and current as the previous, when in reality what I need to do is when the spec says to consume the next character, it actually means that we're going to set the current character to the next character in the iterator. So I'm going to go ahead and next episode fix this up, so hopefully we can actually start parsing in the name of the document correctly or the type of the document correctly. The next major issue that I found was with my overall programming logic and overall design decisions for the parsing logic. We don't even really have the ability to parse the entire first line yet, and the logic is already very convoluted and hard to follow. I was also being a complete brick when I was writing the switch state method, and it was a miracle that is actually working as expected whenever I was testing it previously. This is because I was using break statements as you would inside switch blocks, except the breaks were only breaking out of if statements instead of out of the actual switch block completely. So that's obviously not great. This is something I'm going to remedy by just replacing all of these break blocks with return statements, and it should be okay. The confusion came whenever the spec says to emit a token. Whenever I was thinking you emit a token, I figured you want to return, versus whenever you want to switch to a state, you just want to break. So that's kind of where it happens. So I still need to figure out a good way to manage emitting a token, but we'll figure this out. My general idea, I think, is to have some sort of a stack or a queue or something that has tokens in it that gets emitted, and then have some other method that kind of reads that, kind of how the producer consumer problem works. But we'll kind of see how it goes and see where we go from there. And then finally, since we're not actually building a web browser here, we don't have to follow the spec to a T. I think I was trying to follow the spec a little bit too much, and since we have access already to the entire HTML page, I'm just going to go ahead and cheat a little bit and refactor our byte list into a character list. This will save me from having to do so much casting from a byte to a character. If we really wanted to, we could just do char at and then do whatever char at the string, but I do want to go ahead and make a list because I like using an iterator. I like to be able to use the next character. Fortunately, that's all I've got for this episode if I want to get this out in a timely manner. Hope you all enjoyed the struggle of taking HTML and virtualizing it. I know that I learned a lot through my failures. Hopefully you guys, you learned a little bit as well. Next episode, we're going to come back with what I learned and implement a cleaner, better tokenization algorithm. And hopefully we are able to parse in that pesky first line. I want to thank you all for watching. If you enjoyed, please hit that like button. And if you're new, please hit that subscribe button for more videos like this one. This has been Ethan, Koder. Have a great day, everybody. Peace out.